In our new and modern age, almost all of our interactions have to do something with computers. Traditional computers have used binary bits for decades. However, a new type of computer called quantum computers utilize a new type of bit called qubits to perform calculations faster than ever before. Quantum mechanics, or the study of how particles behave at subatomic and atomic levels, is a key concept used in the making of these quantum computers. A fundamental principle of quantum mechanics is a principle called quantum superposition. Quantum superposition is defined as the ability for a subatomic particle to be able to have two different values for the exact same property at the exact same time. This is an orange. It has the color orange, and that is a property of the orange. Now, if I shrunk it down to a subatomic level, it would be able to have multiple values for that property. It would be able to be blue and orange at the exact same time. I don't really like oranges, but a blue orange, well, I just might try that.
To better understand quantum superposition, let's take a look at an experiment. Imagine we have some subatomic particles, in this case electrons, and we have an electron shooter that can shoot out electrons that have two attributes, shape and color. We can measure these attributes by two different magic boxes we set up. These magic boxes will output the electrons in a certain direction based on what attribute they have. Based on this, we can set up an experiment that first classifies the color and then classifies the shape of each of the color's output. We find that 25% ends up in each of the final outputs for circles and squares based on the classification after the color. Based on this experiment, we can see there's no correlation between shape and color. Now let's change our setup a little bit. Let's first add a shape classifier and toss the results of the square output into our trash can. Let's take those results from the circle output and feed it into a color classifier. And then from that output, let's take the blue and toss them out. Now that we're only left with a red output, we can keep the red and put it into another shape classifier. When we run the experiment, you would expect to get 25% of the total input out of the circle output on the last classifier. However, when we actually run the experiment, it turns out that 12.5% ends up in the circle out, and 12.5% ends up in the square output. The reason this phenomenon occurs is because after we measure the shape for the first time, the particle automatically changes its shape, so it automatically picks between circle and square. Based on the results of this experiment, we can see that a subatomic particle can have two different values for the exact same property at the exact same time. Qubits take advantage of this ability to be able to process data faster.
Computing power is reaching a crisis point. It is expected by the trends that by 2040, our computers will not be able to suffice to our needs. Quantum computing has the ability to fix that. By utilizing quantum superposition, it is able to exponentially speed up calculations. Everything from social media loading times to military simulations to even NASA targeting will all be able to be sped up by quantum computing.